Alright, here we have lecture 1.4, the final lecture of Unit 1, Unit Analysis. So, we'll begin by introducing the concept of a unit. A unit of a quantity describes what that quantity measures or counts, whereas a rate is a ratio of two quantities, and you want to keep in mind the word per often implies division mathematically. So, let's look at this first example here. If Jimmy's car averaged 350 miles, forgot the word miles there, let me add that in, between fuel stops and refueled 12 gallons every stop, compute the average miles per gallon. So miles per gallon literally translates to miles divided by gallons. So that'd be 350 divided by 12. And let me go ahead and grab my calculator real quick. Alright, so 350 divided by 12, we get 29.16 repeating, which is approximately 29.17 miles per gallon. Alright, cool. So let us go ahead and introduce the idea of a conversion factor. A conversion factor is a multiplier for converting units. So examples include 12 inches per every 1 foot, 60 minutes per every 1 hour, 7 days per every 1 week, 20 nickels per every $1, so on and so forth. So these are all conversion factors. So they are multipliers used for converting units. Now mathematically, all of these are equivalent to 1. Because any quantity divided by itself equals 1. 12 inches is the same thing as 1 foot, so 12 inches divided by 1 foot mathematically equals 1. So that's very, very special because mathematically speaking, we can multiply any quantity by 1 and it will maintain the same value. So that allows us to multiply by conversion factors while maintaining the same value. And note, you can use the reciprocal for any conversion factor, right? I can use 12 inches per every 1 foot or 1 foot per every 12 inches, depending on which way I want to do the conversion. And the trick with using conversion factors is every time you use a conversion factor, a unit should cancel. So you want to let the units guide you. Let's demonstrate this with an example. We got 102 inches. We want to convert to feet. So when we use our conversion factor, if we want to cancel out inches, we'll want inches on the bottom, feet on top. It's 1 foot per every 12 inches, and there we have it. Note that the inches cancels out, and we're left with the feet, so that tells us we got the conversion factor set up correctly, and we get 8.5 feet. Cool. How many seconds are in 1 day? So 1 day. So we can use a conversion factor. Well, we don't have to use a conversion factor. We know 1 day is 24 hours, and then we can convert from there. So if we want to cancel hours, we'll put hours in the denominator, minutes on top. So 60 minutes per 1 hour. That cancels out. And if we want to get from minutes to seconds, we'll put minutes in the bottom, seconds on top. Units cancel. 60 seconds per 1 minute. Notice the only unit left here is seconds. That tells us we've done the conversion correctly. So we go ahead and multiply, and you get 86,400 seconds. So let's look at another conversion factor problem. A baker bakes the same pastries every day. If he uses 21 dozen eggs per week, then how many eggs does he use each day? So the word per implies division. So 21 dozen, that's 21 times 12, which is 252. So he's using 252 eggs per division bar every 1 week. So we want to convert from eggs per week to eggs per day. So if we want to convert away from weeks to days, we'll put weeks on top, days on the bottom. Note that units cancel, and it's 1 week per every 7 days. Alright, which leads us to 36 eggs per day. Cool. Now, let's look at this next example. If you need 120 square feet of carpet, but the store sells carpet by the square yard, how many square yards of carpet do you need? So here we need to make the conversion factor, or derive that conversion factor. So we need to come up with a conversion factor before we can do the conversion. And the reason we need to come up with a conversion factor is we don't know how many square feet are in a square yard. Now we know 1 square yard is 1 yard by 1 yard. That's what squaring means. But each yard is 3 feet. So 1 yard by 1 yard is the same thing as 3 feet by 3 feet. And there we have it. 1 square yard equals 9 square feet. So now we can go ahead and do the conversion. We got 120 square feet. So let's go ahead and use our conversion factor. So if we want to cancel that, we'll put square feet on bottom, square yards on top. And we know it's 9 square feet for every 1 square yard. And there we can arrive at our conclusion. It's 13.3 repeating square yards. So 120 square feet is 13 1/3 square yards. Alright, let's look at the next example. We got a bullet going 2,600 feet per second. What is that in miles per hour? So we got 2,600 feet per every 1 second. And what we want to do is go ahead and start converting. So if we want to go from feet to miles, we'll put feet on the bottom, miles on top. Use the conversion factor, so 1 mile is 5,280 feet. So we're now in miles per second. We want to get to miles per hour. So if I want to convert from seconds, I can convert from seconds to minutes. Seconds goes on top so that it cancels, and it's 60 seconds per every 1 minute. And now we can get from minutes to hours, so minutes on top, hours on bottom. Note the unit cancels. Every time you use a conversion factor, a unit should cancel. 60 minutes per 1 hour, and we are ready to do the computation. So let's go ahead and do that real quick. Alright, and we get, let's see here, approximately 1,772.73 miles per hour. Miles per hour. So, moving pretty quick. Let's go ahead and look at this example. Now, these numbers are real, but they're a bit outdated. So this is data from a year or two ago. If you look at it today, luckily gas is a bit cheaper in Paris than it was at the point in time I collected these numbers. But let's go ahead and convert it. So, no, you won't have to memorize a bunch of conversion factors. They'll be provided. So here we know, or we'll be provided that 1 euro is 1.14 US dollars, and 1 gallon is 3.79 liters. Alright, so let's go ahead and do our conversion factor. Gas in Paris is 1.57 euros per liter. So we can convert from euros to dollars by putting euros on the bottom so that it cancels, US dollars on top. Then it's 1.14 US dollars for every 1 euro. So we're now in dollars per liter. Let's go ahead and convert from liters to gallons. So we'll put liter on top, so it cancels. And we can get from liters to gallons. Then it's 3.79 liters for every 1 gallon. And let's go ahead and round that, or multiply it. And we get 678. So it was 678 per gallon at the time of this measurement. So as you can see, that is a huge difference. So it's very, very important that we take into account the units, right? At first glance, 1.57 euros per liter sounds like it's cheap, but it's really not. I mean, 1.57 euros per liter means it's costing almost $7 a gallon. All right, so let's look at another problem that kind of has to do with vehicles and gas. Your destination is 90 miles away. Your fuel gauge shows your tank is 1/4 full. Your tank holds 12 gallons, and your car averages 25 miles per gallon. Alright. So we need to go 90 miles. So what we're going to do now is figure out our range, how far we can go with the gas we have. So if we have 1/4 of a tank, well, that's 1/4 of 12 gallons, which is 3. So we have 3 gallons of gas. Alright, we can convert those 3 gallons of gas into distance traveled by applying our fuel efficiency. And it says we get, let's see here, so we'll put gallons on top, gallons on bottom, miles on top. We're getting 25 miles per every 1 gallon. So that tells us our car can go 75 miles. We need to go 90, so that's not enough. So we will need to stop for gas. Alright, so we're done with those basic conversion factors. Let us now introduce the metric system. So the metric system uses those base units and prefixes listed there: kilo, hecto, deca, the base unit with no prefix, deci, centi, milli. The idea with the metric system is you just have to move the decimal, since each prefix is a power of 10. So let's start with 7 kilograms. So if we look at our prefixes, kilo, hecto, deca, the base unit, deci, centi, milli, we're starting at kilo and ending at decigram. So that's 1, 2, 3, 4 to the right. So we move the decimal 1, 2, 3, 4 to the right. Eggs in the carton. And there you have it. The answer is 70,000 decigrams. So you can see converting with the metric system is pretty quick. We need only move the decimal. So let's do it again. We got kilo, hecto, deca, base unit, deci, centi, milli. This time we're going from millimeters to meters. So starting at millimeters and going to meters, that's 1, 2, 3 to the left. So we go 1, 2, 3 to the left. There's our answer, 0.7683 meters. Alright, cool. So let's put this to work in a problem that requires both the metric system and conversion factors. So we got a baseball that's going 90 miles per hour. We want to convert that to meters per second. So it's 90 miles per every 1 hour. So let's convert to seconds. So if I want to get rid of hours, I'll put hours on top, minutes on bottom. And then if I want to cancel out minutes, I'll put minutes on top, seconds on bottom. Notice I'm letting the units guide me. Then I'll go back and add the numbers. It's 1 hour per every 60 minutes, 1 minute per every 60 seconds. We're now in miles per second. We can get from miles to kilometers. Put miles on bottom so that it cancels, and kilometers. And it's 1.61 kilometers per every 1 mile. Alright. So let's go ahead and compute that. So we got 90 times 1.61, which is 144.9. And then we have 3,600 in the bottom. That's seconds at the bottom. And let's go ahead and do our metric conversion. So right now we're in kilometers and we want to convert. So it's just a matter of moving the decimal. We want to get from kilometers to meters, so that's 1, 2, 3 to the right. So move the decimal 1, 2, 3 to the right. We're now in meters. So we can go ahead and type that into our calculator now. So that's 144,900 divided by 3,600. And we get exactly 40.25 meters per second. So that baseball is going a little over 40 meters a second, moving pretty quick. All right, let's look at another problem that requires some metric conversions. And this one takes some careful reading. We've got a child weighing 15 kilograms that has an ear infection. Doctor orders antibiotic dosage of 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. All right, so we need to figure out how much medicine the child needs every 12 hours. Well, we're using body weight to determine daily dosage, so we want to convert. We have 15 kilograms of body weight. And we can use a conversion factor. If we want to cancel out kilograms of body weight, we'll put that on the bottom. And we want to convert that to milligrams of medicine. And the doctor says we want to go ahead and give the little tyke 30 milligrams per every 1 kilogram of body weight. And that's per day. So that is 450 milligrams per day. So this is where we want to think about this carefully. The kid needs 450 milligrams of medicine per day, but the kid isn't supposed to take it all at once. They're supposed to take it every 12 hours. So we need to split that up into 2 doses. Well, we just cut it in half. 225. Every 12 hours. So they need 225 milligrams every 12 hours. That means they're taking their medicine every 12 hours, and each day they're getting a total of 450 milligrams of medicine. Alright, let's talk about the last topic for lecture 1.4. No, and for unit 1. Sometimes to convert we need to use conversion formulas. A great example of this is temperature. So there is no conversion factor between, say, Fahrenheit and Celsius. Instead, there is a conversion formula. So we're going to go ahead and use that. So we know Fahrenheit equals 1.8 times Celsius plus 32. Kelvins equals Celsius plus 273. So we want to go from Fahrenheit to Celsius. If we look at our formula, F equals 1.8 C plus 32, we know that the Fahrenheit is 98.6. So we set F to equal 98.6 and solve from there. So we'll have to subtract 32 from both sides. Do a little bit of algebra here. That will get us 66.6 equals 1.8 C, so divide both sides by 1.8. Just doing a little bit of basic algebra here to get our conclusion. So 66.6 divided by 1.8 is 37. Equals 37. So there's our answer. And for those of you that work in the medical field, this number should look familiar to you. 98.6 is standard healthy body temperature. So in Fahrenheit, that's 98.6. In Celsius, that would be 37. Let's try going the other way around. Same formula. But let's go ahead and convert from Celsius to Fahrenheit. So we know the Celsius is 100. So we set the Celsius value to 100. Now notice the F is already by itself, so we don't have to do any algebra. We just gotta, compute that number. And we get 212. This should make sense because this is the boiling temperature of water. Alright, let's convert 100 degrees Fahrenheit to kelvins. Now if you look at the formulas, we do not have a conversion formula from Fahrenheit to kelvins. But we can use formulas to get from Fahrenheit to Celsius, and then we can get from Celsius to kelvins. So to get from Fahrenheit to Celsius, we use this formula. So we'll plug in 100 for F and solve accordingly. So subtract 32 from both sides. That gets us 68 equals 1.8 C. So divide both sides by 1.8. And we arrive at our Celsius value, which is 37.7 repeating. Alright, now we can go from Celsius to kelvins. So kelvins equals Celsius, which we know to be 37.7 plus 273. So that's a pretty easy formula to work with, and we arrive at our conclusion. 310.7 repeating kelvins is the answer. Alright, and that's a wrap for the lecture.